Okay, we're going to pick up where we left off in the last video. 3 more examples here of integrating the exponential function. And these 3 examples are definite integrals, so the process is similar to the previous 4 examples, but we are going to evaluate our integrals from the lower to the upper limit as well. So in our first example, number 5, we are trying to integrate the e to the negative x function. So it is not e to the positive x function, so once again we have to use a u sub. So I'm going to call my u the negative x power. Well, not power, but u is negative x, which makes du negative 1, or just negative dx. So I can rewrite my integral, but I don't want negative dx, I just want dx, so I'm going to divide by a negative 1. So when I rewrite my integral, it is e to the u power, and it's not just du, I've got that negative out front. And then I have a decision to make. I can either change my limits, which currently are in terms of x. I can change those to be in terms of u, so that I do not have to do any more substitution, and I can just integrate and evaluate. And that's the way I'm going to do it. The other way you could finish this problem is you could leave your limits in terms of x, integrate, but then you would have to resub back in the negative x where the u is and finish the problem. But when you're doing definite integrals, doing that change of limits so that everything is with respect to the same variable makes things easier. And it's a simple process. If down here x equals 0, then I can put a 0 in where I did my u sub and decide what is u going to be. And in this case, the opposite of 0 is still 0. And in terms of my upper limit, x equals 1, so when I put a 1 in, it becomes negative 1, so u becomes negative 1 in my upper limit. Now I'm ready to do my integration and evaluation. So this is going to equal, got my negative out front, integral of e to the u du is e to the u. Normally we would say plus c, but in this case we are doing a definite integral, so there's no plus c. Instead we evaluate from 0 to negative 1. Now sometimes students will say, wait, isn't that backwards? Isn't it supposed to go negative 1 to 0? Which is true. However, when you are evaluating, the signs will take care of themselves by doing the upper limit minus the lower limit. Now what I'm also going to do before I evaluate is I'm going to take that negative and I'm going to put it out front, so that I only have to deal with it at the end. So I have the negative out front. Now I'm going to put in my upper and lower limits. So e to the negative 1 power minus e to the 0 power. If this were a free response question, we are done. However, let's see what kind of simplifications we can come up with here. When I distribute the negative sign, I get negative e to the negative 1 power. When I distribute the negative to the negative there, I get a plus, and then e to the 0 power is 1. That is a completely acceptable answer, but you could see it written a variety of other ways as well. So that negative e to the negative 1 power could be written as negative 1 over e plus 1. And when I scroll down to the scanned answers, this is pretty close to the answer they have. They just switched the terms around and wrote 1 minus 1 over e, which is equivalent. So there's an example of how to integrate the exponential function, and you're doing a definite integral rather than an indefinite integral. Number 6 is another example of that. I'm going to erase some of this work here so that we can have a bit more room. Alright, so we've got the integral from 0 to 1 of e to the x over 1 plus e to the x dx. And when you look at this one, you got to decide what am I going to call my u here? So as I take a look at this problem, I'm thinking to myself, well, I have e to the x power, so I don't need to call my u x. That would be kind of silly. So is there something else that I need to call my u? And maybe it's 1 plus e to the x power. So let's try that. Let's try u equals 1 plus e to the x power. Okay, if that is our u, then our du is, well, the derivative of any constant is going to be 0, so that's gone. The derivative of e to the x is e to the x, technically times 1, but we're not going to write the 1 in, dx. And it is kind of disguised in there, but 1 plus e to the x is now going to be down here and become my u. And then that e to the x dx is my du. So I'm ready to rewrite this integral in terms of u. And what it ends up being is 1 over u, because that entire 1 plus e to the x power is now u. And then e to the x dx becomes my du. So I have 1 over u du. Nice little review of something that we just did. This is going to end up being the natural log of the absolute value of u. Now before we get to the integrating, we are going to change our limits. So over here, these are in terms of x, and because we don't want to have to do all kinds of resubbing, we're going to change our limits to be in terms of u. So our lower limit was x equals 0 before. When we put a 0 in for x here, e to the 0 power is 1, 1 plus 1 is 2, so our new lower limit is 2. Our upper limit was x equals 1, but if we put in a 1 here, we end up getting e to the first power plus 1, which there's nothing more we can do with that other than just say e plus 1. And now we are ready to integrate and evaluate. So the integral of 1 over u du is going to equal the natural log, and normally we would say of the absolute value of u, but in this case we can just say the natural log of u, because our limits go from 2 to e plus 1, and because our limits are positive, we don't have to worry about taking the natural log of a negative number. So now we can evaluate. We end up with the natural log of e plus 1. And keep in mind that e plus 1 is all part of what's being natural logged there, minus the natural log of 2. And there are certainly some things that we could do in terms of rewriting, but they're limited in this case because we don't have natural logs of products or quotients, or there's no powers going on in there. So if we scroll down, you see the same answer, natural log of 1 plus e. I believe I wrote e plus 1 minus the natural log of 2. So there's a second example of integrating an exponential function, and it's a definite integral. Let's do one more. Number 7. Integral from -1 to 0 of the function e to the x times the cosine of e to the x dx. So we've got a product, we've got an exponential function, we've got a trig function, there's a lot going on here. Clearly we need a u sub, and sometimes it's as easy as e to the x power, which is exactly what we're going to do here. So if we call our u e to the x power, that makes our du e to the x, technically times 1, dx. But by doing that, what we now have for our integral, which I'm just going to write below here, is the integral of cosine of u, whoops, and then our e to the x dx is our du. So now we're going to be integrating a trig function, which again is a good review. We're going to change our limits again. They are currently in terms of x up here. We want to change them to be in terms of u. So our lower limit is negative 1 in terms of x. If we put a negative 1 in over here, we get e to the negative 1 power, which could also be written as 1 over e. And when x is 0, e to the 0 power is 1. Now we're ready to integrate. So the integral of cosine of u is simply sine of u. And we're going to evaluate that from e to the negative 1 power to 1. So we get the sine of 1 minus the sine of e to the negative 1. And that could be rewritten as the sine of 1 minus the sine of 1 over e. If we scroll down, they have it the same way we do up there, sine of 1 minus the sine of e to the negative 1 power. So those are our examples of integrating exponential functions for definite integrals. And we'll move on to our next topic.